Jai Hind to all. My name is Dr. Divya Sharma, Assistant Professor in Ajay Kumar Garg Engineering College, Ghaziabad. Now today's video lecture is on OSI model. This topic is from Data Communication Network subject and its code is BEC062. Now first, what do you mean by data? When we are communicating from sender to receiver, so we have to send some data from sender to receiver. Data means information. So information, it may be in digital form. So when you are sending information, so information you are sending from sender to receiver, and sender is your computer, and you can send data information in binary, digital form, or raw data. It is used to describe data in its most basic digital format. So this is data. Data means information. Next is communication. When you are sending data from sender to receiver, so we have to send data through a communication link. So that is your communication link is known as channel or medium. Channel, it may be wired or wireless. So there is a very important this is very important term, communication, because when we are sending data from sender to receiver, it is very important that there is some media when we are sending data from sender to receiver. Now when we are sending data from sender to receiver, or one node to another node, or one computer to another computer, so we are sending data in a network. Network is a collection of computer, server, devices, nodes, mainframes, servers. So this is a collection of all these computers or devices, that is known as network, when we are sending data from one device to another device. Now a computer consists of two or more computers in a network. It means it may be two computers are there, or more than two computers are there in a network. So when we are talking about this network, so we have to share information from sender to receiver through one computer, from one computer to another computer, or one computer to many computers. So we are sharing resources such as printers, CD, exchange files, or allow electronic communication. The computer on a network may be linked through a cable, or telephone lines, or radio waves, or satellites, infrared light beams. So this is a media in between sender to receiver. Now what are the applications of network? Network, instant messages, it may be used for instant messages. Email, when we are sending email from sender to receiver. File transfer application, if we have to send file from sender to receiver, so we can use this application. Now information sharing using web or internet, mobile data communication, video conferencing, optical network based application, and high speed data sharing between computer or devices. So these are the applications of network. Now we will study OSI model. Now first, there is a ISO. ISO is an organization established in 1947. It stands for International Standard Organization. It is a multinational body dedicated to worldwide agreement on international standards. Now this is an organization, and OSI is a model. So this ISO standard, this organization covers all the aspects of network communication, that is OSI model. And now OSI model, you can see this is first introduced in late 1970s. So in this OSI model, we have to study this layered architecture, peer-to-peer process, encapsulation. So these topics we will discuss in further slides. Now first we will study this 7 layers are there in this OSI model. Now this is top layer, application layer in OSI model. 6th means second most is presentation layer, then session layer, transport layer, network layer, data link layer, physical layer. So each layer have individual means work in this OSI model. That if we are talking about this physical layer, so physical layer is used when we are sending bits, means data in form of bits from sender to receiver. Now data link is when we are sending data from sender to receiver, so it may be in form of packets. So data link layer, its work is to send packet from sender to receiver. Now what do you mean by network? Network layer, its work is to when we are sending data from sender to receiver, so there is first we have to describe optimal path. This is for bit stream, when we are sending data from sender to receiver in form of bit stream. Now data link layer is for packet or frame, in form of frame we are sending data. Now in network optimal path we have to choose. Now in case of transport layer, its work is to establish connection that may be TCP or in form of UDP. Now TCP means transmission control protocol, it is wired connection, and UDP is user datagram protocol, it is wireless. So here we have to establish the path that is wired or wireless. Now session layer, what is the work of session layer in OSI model? So session layer is that we have to send data from sender to receiver, and we have to synchronize one data to another data. Let it be, this is your data 1, its header is this one, this is data, this is trailer. Now this is data 2, so it has some header and trailer. So we have to synchronize this data to this one, means this, if this is data 1, this is data 2, so we have to synchronize in between these two data. So this is the work of session layer. Now presentation layer. So here when we are sending data from sender to receiver, that may be in form of encryption form, encrypt form, or compression form, or data is in form of translation, means we are translating data from, when we are sending data from sender to receiver. Now this is application layer. So here we have to this is a user interface. So this is a short description of all these 7 layers in an OSI model. Now we will discuss each layer one by one briefly. Now first we will discuss when we are sending data from sender to receiver. So how we can send data from sender to receiver. Are there intermediate nodes are there, or and if there are intermediate nodes in between sender to receiver, so where they are interfacing. Now you can see this is device A, this is sender, and this is device B, this is receiver. When we are sending data from sender to receiver, there are some intermediate node. Let it be, this is intermediate node 1, this is intermediate 2. When we are talking about OSI model, means 7 layers are there at the sender side and 7 layers are there at the receiver side. So intermediate nodes are existing in between only physical data and network link layer. So this is intermediate node 1, this is intermediate node 2, and they are interfacing with this network layer, data link layer and physical layer only. Means these 2 intermediate nodes are existing in between these 3 layers only. And here if we are talking about this transport layer, session layer, presentation layer, application layer, so these are peer-to-peer protocol, means point-to-point protocol interfacing is there in between application layer of sender and application layer of receiver. So if we are talking 7 layers at the side of sender, so there is interfacing in between application layer to presentation layer, presentation interfacing in between presentation layer to session layer. Now means there is an interfacing in between each layer of this sender side, and here also at the receiver side there is an interfacing in each of the layer of this OSI model. Now we have to send data from sender to receiver. So here this is this is application layer, this is presentation layer, this is session layer, this is physical layer, data link layer, network layer and transport layer. So each layer have some individual work. So in the physical layer we have to assign here bit stream, then here we have to data is in form of packets. Now here data is, we have to establish a connection here. Now here means we have to find out the routing is optimal routing, we have to find out here at this level. Now this is physical layer, data link layer, network layer. Now transport layer means we have to establish connection between sender to receiver, that is wire or wireless. Now here data at this level, session layer, so there is a synchronization. Now here presentation layer means data is encrypted in form, and here is application layer, means if we have to send data from sender to receiver, first sender send data, some say data to application layer. So there is interfacing with the user. Now application layer says, then data is sent to presentation layer, then session layer, then this is transport layer, then network layer, then data link layer, then physical layer. Now your data will send through this transmission media to this receiver part. Now again, when you are sending data from physical layer to, then it is received by the physical layer of the receiver side. Then again your data is sent in form of packet to this data link layer, then network layer, then transport layer, session layer, presentation layer, application layer. Then your data is received by this receiver. Means at the sender side there are seven layers, and the receiver side there are 7 layers. So data is sending from this sender to this application, these layers, and through this transmission media we are sending data to receiver side. So there is an exchange, of message from sender to receiver in this form. Now layers in OSI model. So these all layers, 7 layers are there in this OSI model, already discussed in short in the previous slide. Now we will discuss here briefly that physical layer is responsible for movement of individual bits from one hoop to another hoop, or one node to another node. Now you can see in the previous slide that there is an interfacing to this physical layer with the data link layers. Means your data is coming from this data link layer to physical layer in form of bits here. Now data is sending to receiver side through this transmission media, and data is received at the receiver side in form of bit stream only. And there is also a interfacing in between data link layer and physical layer. So this is the work of physical layer. Now we will discuss physical layer interface for transmission of information. Now second, it defines rules by which bits are passed from one system to another system through a communication media. Now it covers all mechanical, electrical, functional and procedural aspects for physical communication. There are such characteristics such as voltage level, timing of voltage changes, physical data route. So there are some characteristics they have to follow. Now concerned with line configuration, physical topology and transmission media mode is there. Now second is data link layer. So if we are talking about this data link layer, this is responsible for moving frames from one node to another node. Already discussed in the previous slide that we have to send data in form of, if we have to send data in form of packet, then this is the work of data link layer from sending from one node to another node. Now there is an interfacing in between network layer and data link layer, and data is in form of, there is a data, here is a header and there is a trailer. So frame is in this format, header, data and trailer. Now header is, let it be you are assigning some unique number or unique something unique for this data. So if let it be its serial number is 1, for this data its serial number is 1. So when we are sending data from sender to receiver, so when we will receive this data at the receiver side, so its serial number is 1. If we are sending data and serial number is 2, so there is a synchronization in between this data 1 and data 2. It means first we will receive this, if we are sending this data 1 from sender to receiver, so receiver receive first data 1 then data 2. So there should be a synchronization between data 1 and data 2. So here data is in form of format, in form of frame, where there is a header, data and trailer. Trailer is used to synchronize, or is used to, if you have to add some extra bits in the in data in frame, then we can add in this trailer. Now data link layer attempts to provide reliable communication over physical layer interface. Now it breaks the outgoing data into frames and reassemble the received frames. Now create and detect frame boundaries here in the data link layer, and it handles errors by the implementation. It means when we are sending data from sender to receiver, if we are when your data is received by the receiver, then receiver will send an acknowledgement from receiver to sender side, then it means your data is successfulully sent from sender to receiver. So implementing an acknowledgement or retransmission is seen. It means if your data is not, if sender is not getting a proper acknowledgement from the receiver side, then sender responsibility is that the sender have to send data again, means retransmit data again. Now data link layer is used for implementation flow control, responsible for error control. If there is error, so they have to detect. Now support point to point as well as broad communication, and it supports simplex, half duplex and full duplex communication. Now if we are sending data from one node to another node, or hoop to hoop delivery, this is your AND system, means let it be this is your sender and this is your, these are your receivers. We have to send data from this sender to this system D or this F system. Now when we are sending data from this sender to receiver, so there are some intermediate nodes are there. This is router B, this is router C, this is router E. If we are sending data from A to D, so intermediate nodes are B and C, and intermediate nodes means there is an interfacing in between physical layer and data link layer, means intermediate nodes are in between physical layer and data link layer if we are sending data from sender to receiver, node to node delivery. So this is the description of hoop to hoop delivery. Now third one is network layer. Network layer is responsible for the delivery of individual packets from source host to destination host. Now here your data is sending from transport layer to network layer. So there is interfacing in between transport layer and network layer, and data is in form of packet. Here what is the work of this network layer? Network layer is to select the optimal routing for this layer. Now here we have there is interfacing between transport layer and network layer to this data link layer, and at the receiver side also there is an interfacing between transport layer and network layer from this data link layer. Now network layer, it implements routing of frames or packets through the network, defines optimum path, and defines, means here also logical addressing is to be assigned for the packets, handle congestion in the network. If there is a congestion in the network, it will be handled by this network layer. Network layer also define how to fragment a packet into smaller. If it means if a packet is very large, then it have to divide into small segments, then only we can send data from sender to receiver in form of small packets. And there is a synchronization is also very important in between all these small packets. Now source to destination delivery. If you have to send data from this A to D, so if we are talking about source to destination delivery, so intermediate nodes are there here in between network layer, data link layer and physical layer. So we can send data from this node to this intermediate system, then this node to this intermediate system to this one through this link, then this AND system D through this link. So this is the procedure how we can send data from source to destination delivery or hop to hoop to delivery. Now the next layer is transport layer. Transport layer is responsible for the delivery of a message from one process to another process. So here if we have a large packet, then we have to divide that packet into small segments, and this is, let it be, this is segment A, B, C, means this is header is assigned to this data, then header is just assigned to this data, and header is assigned, means small segments, it is divided into small segments when we are sending data from sender to receiver. Now there is interfacing from session layer to transport layer, then interfacing in between from transport layer to network layer, then that data is sending from to physical layer, then data link layer, then physical layer, then transmission media. Through this transmission media, data is sent to physical layer, then data link layer, then network layer, then this transport layer to session layer. So this is the process how we can send data from sender to receiver. Now what is the purpose of this transport layer using in the in all these layer in this OSI model? The purpose of this transport layer is to provide a reliable mechanism for the exchange of data between two processors in different computers, ensures that the data units are delivered error free, ensure that data units are delivered in sequence, no loss of or duplication of data, and provide connectionless or connection oriented service, and provides connection management, and in the last multiple multiplex connection over a single channel. So this is the purpose of this transport layer. So here we have to send data. Process to process delivery is there, happens here. So if let it be, this is process A, B, C, right, and this is sender side, this is receiver side, this is process I, J, K. If we have to send this process A to process I, so first, and through this internet we can send this process A to I. So first this process A from sender side to network layer, then host to host delivery, transport layer, process to process delivery, means we can send this process A to process I through this internet only, and we have to follow all the layers process, then only we can send data from physical layer to of sender to physical layer of receiver side. Then the fifth layer is session layer. Session layer is responsible for dialog control and synchronization, means this session layer provides synchronization of data in between many data, means if we are sending many packets are there from sender to receiver, then synchronization provides by this session layer. So there is interfacing in between presentation layer in session layer and session layer to transport layer. So here when we are sending data, let it be data 1, 2, 3, 4. So there is a synchronization is provided by this session layer. So this data is sending from sender to receiver, from this presentation layer to session layer, then transport layer, then network layer, then data link layer, then physical layer, then transport, then media, then the data passes through the media, transmission media, then to physical layer, data link layer, network layer, transport layer, then session layer to presentation layer, then application layer, and data is received by the receiver. Now what is the purpose of this using session layer? Now session layer provides mechanism for controlling the dialogue between two end systems or two computers or two devices. It defines how to start, control, and or if you have to end the conversation from sender to receiver. So this is the purpose, this is the work of this session layer. This layer requests for a logical connection to be established on an end user request. Any necessary logon or password validation is also handled by this session layer. Session layer is also responsible for terminating the connection, and this layer provides services like dialog discipline, which can be full duplex or half duplex. Session layer can also provide checkpoint mechanism also handled by this session layer. Now next, presentation layer. Again, presentation layer is responsible for translation, compression, and encryption of the data. So there is interfacing in between application layer to presentation layer, then session layer. So here we can encrypt the data from sender side and we can decrypt the data at the receiver side. Now presentation layer defines the format in which the data is to be exchanged in between two computers. It handled compression and data encryption or translation of the data by this presentation layer. Now the last layer is application layer. Application layer is responsible for providing services to the user. So here these are your services provided by the application layer, and there is interfacing in between application layer to presentation layer. So we are sending data from user to application layer, then to presentation layer, then same process will be followed by the receiver side. Now what is the purpose of this using this application layer? Application layer interacts with application programs, and it is the highest level of OSI model, and at the lowest level of OSI model physical layer is there. Now application layer contains management function to support distributed applications. Examples of this application layer like file transfer protocol, electronic mail, remote login, these are the examples of application layer. Now this is the summary of all these layers. That physical layer to transmit bits over a media to provide mechanical and electrical specification. Data link layer to organize bits into frame and to provide hope-to-hope delivery. Network layer to move packets from source to destination to provide inter-networking. Transport layer to provide reliable process-to-process message delivery and error recovery. Session layer to establish, manage and terminate the session from sender to receiver. To presentation layer to encrypt, translate or compress data. and application to allow access to network resources. So this is the summary of all these 7 layers in OSI model. So these are the references. You can refer this book, Forozon, Stalling, Tannenbaum, these are textbooks. So you can refer these books and reference books like BP Rathi, Ajit Pal and so on. So these are the references, you can follow these references.